At first, the world was treated to breathtaking images of the cosmos captured by NASA's James Webb Space Telescope, JWST. By returning a series of startling new images, this ambitious and once again heavy endeavor has changed our understanding of the universe. Researchers and fans alike have been taken aback by these recent images, which include tidbits of information that cast doubt on long-held theories and reveal previously unexplored areas of study. These images push the boundaries of human understanding to unusual places and provide us a quick glimpse into the most remote and mysterious parts of the cosmos. For more curated content, click the like and subscribe buttons before we start. With its sophisticated infrared capabilities, the JWST, which was supposed to replace the Hubble Space Telescope, has exceeded expectations. Because of this, it can see farther into the cosmos than any previous instrument. The James Webb Telescope mostly operates in the infrared spectrum, but Hubble provided incredible views of the cosmos in visible light. Because of this power, it can cut through clouds of cosmic dust and solve the puzzles of star formation, black holes, and the early cosmos. The most recent images from the telescope have shown us newly unexplored parts of the universe, providing fresh insights into long mysterious phenomena. Area of space so far that it dates back only a few 100 million years after the Big Bang is depicted in one of the most important images the JWST has returned. The dark ages of the universe are a time in cosmic history that has mostly remained mysterious. The cosmos started to emerge from its early state during this period, when the first stars and galaxies formed. Researchers can now sort out the events that molded the early cosmos, because they are seeing evidence of these earliest structures with unprecedented clarity for the first time. These new images show stars being born in stellar nurseries, which are massive billows of gas and dust. These areas, where gravity arranges enormous masses of matter to ignite the nuclear processes that generate stars, are some of the most violent and tumultuous in the universe. Intricate details of this process have been documented by the JWST, which provides a window into the life cycle of stars in a manner never before achievable by displaying stars at various stages of development. Cosmologists can discover more about the circumstances surrounding star birth and how these processes have evolved over billions of years by examining these images. The James Webb Telescope has not only photographed star nurseries but also far-off planets, many of which have never been seen before. We are viewing these worlds as they were when the universe was still in its early stages because they are so far away that it has taken billions of years for their light to reach us. Complex phenomena within these galaxies, including as enormous black holes at their centers and star clusters that are much older than our own Milky Way, have been made visible by the telescope's unparalleled resolution. These black holes are especially intriguing since they contradict everything we now know about the formation and evolution of these phenomena. Compared to their stage in the universe's history, some of the black holes in these images are remarkably active and substantially larger. Black holes are thought to begin as tiny, dense objects that gradually gain mass over time by consuming nearby matter, according to theories regarding their evolution. Cosmologists have been forced to re-evaluate their concepts of black hole evolution, though, as the JWST data indicates that certain black holes may have formed fully developed or experienced rapid expansion. Questions concerning the formation and evolution of galaxies themselves are also brought up by the images of these early galaxies. Despite being so young in cosmic terms, some of the galaxies observed by the JWST are extremely well organized, with distinct spiral arms and core bulges. It was previously thought that because of the violent processes involved in their formation, galaxies in the early cosmos would have been more chaotic and irregular in shape. Thus, this amount of structure is astounding. These well-formed galaxies finding raises the possibility that galaxy formation happened considerably faster than previously believed, which has important ramifications for our understanding of the early history of the universe. Additionally, the JWST has offered a startling new viewpoint on exoplanets, one of the universe's most mysterious phenomena. Even though thousands of exoplanets have been found in recent decades, little is known about their atmospheres and potential for life support. These are planets that circle stars outside of our solar system. Researchers are now able to examine the chemical makeup of exoplanet atmospheres more thoroughly than ever before because to the James Webb Telescope's infrared capabilities. Unexpected discoveries, such as the existence of water vapor, methane, and other organic molecules on some exoplanets, have been made possible by some of the new images and data. These findings are particularly thrilling since they advance our understanding of one of science's most important questions. Are we the only beings in the universe? Although the discovery of organic compounds in the atmosphere of an exoplanet does not prove that life is present on these planets, it does indicate that the elements necessary for life are more prevalent in the universe than previously believed. These findings might change our understanding of life in the cosmos if they eventually result in the discovery of habitable worlds outside of our solar system. The latest images from the JWST also shed light on the last phases of star life. Detailed images of supernova remnants, vast, vibrant clouds of gas and dust left over after a star explodes, have been obtained by the telescope. Since many of the heavier elements in the cosmos are formed there, these relics are not only aesthetically pleasing but also important from a scientific standpoint. Large amounts of energy are released when a star explodes as a supernova, fusing lighter elements like helium and hydrogen into heavier ones like iron, carbon, and oxygen. After being dispersed throughout space, these elements eventually form new planets, stars, and eventually life itself. The new images from the James Webb Space Telescope, which explore the early cosmos, have given us a glimpse into a cosmic narrative that was previously difficult for us to fully understand. These images are especially poignant because, in addition to their beauty, they reveal hitherto unattainable mysteries about the cosmos. These hitherto unseen views of far-off galaxies, nebulae, and cosmic formations are making us re-evaluate our preconceived notions about the cosmos. One of the most astounding discoveries revealed by the JWST involves something far closer to home: the outer regions of our own solar system. This is in contrast to the images of far-off galaxies and exotic phenomena that have caught the public's attention. By examining the icy worlds at the solar system's periphery, the telescope's infrared sensors have been able to uncover new information about their surface characteristics and composition. For instance, a detailed image of Pluto's moon Charon was obtained by the telescope, displaying a complicated terrain of mountain ranges and frozen areas that were previously hidden from our view. Scientists may gain a better understanding of how planetary bodies arise in cold, far-off parts of space thanks to these studies of the outer solar system. Astronomers have long been baffled by the Kuiper Belt, a large area of space beyond Neptune that is home to thousands of frozen objects. The detailed observations of these objects by the JWST may shed light on the formation of planets in the farthest regions of planetary systems and reveal hints about the origins of our own solar system. In addition to making specific discoveries, the James Webb Space Telescope is assisting in the resolution of one of cosmology's most important questions. How did the universe come to be as it is today? The telescope is contributing to the creation of a cosmic history timeline by taking pictures of planets, stars, and galaxies at various points in their evolutionary histories. By tracking the evolution of galaxies and stars across billions of years, these data give scientists a more comprehensive understanding of the past, present, and future of the cosmos. The discovery that the early cosmos was far more active than previously believed is one of the major findings from the most recent images taken by the JWST. The images demonstrate that galaxies are forming more quickly than anticipated, and that powerful star formation bursts are happening quickly after one another. This calls into question the long-held belief that galaxy formation occurred gradually over billions of years in a relatively peaceful early universe. Rather, it appears that galaxies rapidly formed and evolved during the first few 100 million years following the Big Bang, a period of remarkable activity that scientists are only now starting to comprehend. The extraordinary sensitivity of the James Webb Space Telescope is largely responsible for its capacity to peer so far back in time. The telescope can pick up even the smallest traces of light that have traveled billions of light-years across space by using infrared observation. The early cosmos's stars and galaxies emitted this light, which has since been redshifted and stretched as the universe has grown. Scientists may now view things that are so far away that it has taken the light from them nearly the whole age of the universe to reach us thanks to the JWST's capacity to capture this old light. The JWST is offering a fresh view of the universe's structure in addition to seeing far into the past. The images show enormous cosmic webs of galaxies and dark matter that resemble spiders' webs and span throughout the cosmos. The foundation of the universe's large-scale structure is made up of these networks, which are created by the gravitational attraction of dark matter. Scientists aim to gain a better understanding of the role dark matter plays in galaxy formation and evolution by mapping these structures. These massive networks are now more clearly visible than ever thanks to the JWST images, which also provide fresh insights into the makeup of dark matter and its effects on the cosmos. It is becoming more and more obvious that a new era of cosmological discovery is upon us as the James Webb Space Telescope continues to return fresh images. Our knowledge of the universe is being revolutionized by the telescope's ability to view farther and more clearly than any other instrument. It is answering long-standing questions while also posing new ones. A cosmos full of miracles that test our comprehension of space, time, and the essence of reality is revealed by each new image. It is more intricate and exquisite than we could have ever dreamed. The fact that these new findings contradict accepted theories of cosmic development is among their most fascinating features. Consider the theory of cosmic inflation, which postulates that the universe expanded rapidly after the Big Bang. Although the idea has been generally acknowledged, JWST discoveries are demonstrating that the early cosmos might have been much more active than previously thought. Galaxy formation may have taken place more swiftly and under more harsh conditions than typical inflationary models predict. According to the JWST's astonishing detail of the first galaxies produced during the first few 100 million years after the Big Bang, these galaxies seem to be significantly more ordered than previously thought, far from being tiny and chaotic. They are composed of materials that suggest sophisticated chemical compositions and exhibit characteristics like rapid star formation rates. Astrophysicists were forced to re-evaluate their theories regarding the formation of stars and galaxies in the early billions of years of the universe after these findings, which imply that the universe was able to develop more quickly than models had projected. Another major problem is the identification of early supermassive black holes, which are an oddity observed in some of these distant galaxies. Since black holes are generally believed to arise from the fall of large stars, a process that would probably take longer than these early black holes seem to suggest, scientists have long been perplexed as to how such massive black holes could have formed so early in the history of the universe. Evidence of black holes with millions of times the mass of the Sun existing when the cosmos was less than 1 billion years old has been found thanks to JWST's fine imaging capabilities. Important issues concerning how black holes may expand so rapidly in such a short time are brought up by this astounding discovery. A significant new viewpoint on the potential contribution of black holes to the formation of the early cosmos is also offered by these data. Galaxies may have formed and evolved as a result of the energy produced by expanding black holes in the form of radiation and strong jets of charged particles. JWST's photos have contributed to the understanding of this interaction between supermassive black holes and their host galaxies. Scientists can learn more about how galaxies were formed in the first billion years of the universe's history by examining these early black holes and their influence on nearby gas and stars. However, JWST's state-of-the-art equipment light more than only black holes and galaxies. Additionally, the telescope is illuminating dark matter, one of the universe's most enigmatic constituents. In addition to seeing astronomical occurrences, the James Webb Space Telescope is also supplying vital information that advances our knowledge of basic astrophysical processes. The telescope's measurements of the cosmic microwave background, for instance, have improved our understanding of the early beginnings of the universe by illuminating its evolutionary history and the characteristics of dark energy. The chronology of cosmic growth depends on this background radiation, which is a byproduct of the Big Bang. The JWST is also contributing to the definition of our stellar evolution models. Astronomers can study the mechanisms governing stellar nucleosynthesis, the production of heavier elements inside stars, by watching different kinds of stars at different phases of their life cycles. Understanding the distribution of components necessary for life throughout the universe depends on this research. Moreover, scientists can investigate seasonal variations and atmospheric dynamics thanks to the JWST's capacity to record exoplanet atmospheres using transit techniques. Finding possible biosignatures, indications that life may exist on these far-off worlds, could result from such in-depth investigations.